ASCII file format for 3D points. As we can see, this stands for ASCII, and the file format have the following extension. So basically this is a file that can be opened with any text editor, and we're gonna have the coordinates of each point on each line. So to showcase this, I have prepared a file over here. So it will be this one. We see the size is quite large, so over 500 megabytes, and I have the possibility to open this directly within Notepad, and we're gonna have the coordinates of each point. So this will be the coordinate for X, Y, and Z, and this will be a long list with depending on the complexity of the model, there can be several million points. So before I'm gonna open this in CATIA, I'm gonna open the same model within MeshLab. So this will be that. We see bend this ASCII file, drag and drop that, and the software will start the import of that. But before, we need to define some of the pre-open options. In this case, I'm just gonna go with the default because I want all the meshes, all the points that will define the mesh to be added. The main difference between an ASCII file and an STL is that we only have the points. We don't have the mesh that links and the triangulation that defines the mesh. Before I started recording this video, I already opened this model, and we're gonna see how slow MeshLab will read the file in comparison to CATIA. We see that currently we still have 0 vertices, 0 faces, but we see a progress bar at the bottom. If you are not familiar with MeshLab, this is a free software that you can download. Let me Google that. So, since it's still loading, I know that it requires up to 3 minutes on my computer for that model. We're going to see that MeshLab is an open source software that enables processing and editing of 3D triangular meshes. So even though this is not already triangulated, just a point cloud, we have the possibility to open that. And the main advantage is that the software is free, so you can download it over here for different operating systems. There will also be some samples. So I have the possibility to also do some alignment, visualization and presentation, some surface reconstruction that we are also gonna do within CATIA, cleaning meshes just like cleaning within CATIA, and some remesh and measurements. So some of the features go far beyond what CATIA can do, but mostly if you are just interested in defining a 3D mesh based on an ASCII file, you can do that easily. Okay, so let's see if the progress. So we already see that almost 6 million vertices have already been opened, but let me check this video recording to see the time that okay, so we already have around almost 4 minutes since I drag and drop the model, and it's still not fully loaded. We see at the bottom the memory, so this will be the memory for the model, and we see that the model finally opened. The main problem is that since we have almost 18 million points, we're gonna see that the frame rate within MeshLab will be quite low, so something between 2 and 3 FPSs. And this will be that point cloud. If I'm gonna zoom in over here with the default visualization for points, they will be larger, so they won't be that visible. But I'm gonna close this and I'm gonna jump within CATIA and I'm gonna go to shape, digitize shape editor. And if I'm gonna go for file import, I'm gonna see that I'm gonna pick the same model from my desktop, so it will be this one. So format ASCII free. I'm gonna keep the sampling to 100%, just like it was in MeshLab, so that means that all the points will be added. There won't be any preload filter for this. And also scale factor 1:1 because we want the true scale of the model. And this is the main difference. We see how fast CATIA can open that in comparison to MeshLab, which is open source. We see that currently we get not responding within the import, but this shouldn't cause any problem, and usually CATIA manages to recover from this not responding when loading various 3D models. So let me check. I'm just gonna open the record software on the other screen, and let's see how long does it take. So as we can see, somewhere around half a minute, I estimate it requires for CATIA to have this open. It's still not fully loaded, so we still don't have control, but the model should load anytime soon. And as soon as the model will be loaded, we're going to discuss some filtering option that we can apply. One of the main drawbacks is that if you're going to have a lot of noise, so points that have been scanned and misaligned over the surface of the object, it will be a little bit harder to clean that. But we see that the mesh is already loaded and CATIA managed to recover, so it's no longer not responding. I'm going to click OK so that we're going to have the mesh loaded. And we see that the frame rate still is not that great, but it's way better than the one from MeshLab. If I'm going to zoom in, I'm going to see that all those points, so for each we have that individual coordinates, will be like this. But if I'm going to zoom out, the model will look like it's made out of lines, not points. So let's start filtering this, but before I'm gonna start, I'm just gonna copy and paste so that I have the original point cloud open twice. I'm just gonna hide the initial one. I will press F4 in order to jump within a different view. In this case, I can go either within the back view, because we see that when the object was scanned, there is a lot of noise, and also we have the table that the object was positioned. So we're going to need to remove that. So again, I'm going to press F4, or I can go directly within the back view. We see a slight drop in performance, just like we had in over there. So that is the top view. I will go again in front view. So I'm just gonna zoom in to see this better centered, and after that I'm gonna go for the remove option. With the remove option, we need to click on the point cloud that we need to remove, to cut from. So I'm gonna click on that, and after I clicked it once, now I have the possibility to go with a selection mode. I will go with wrap, rectangular, and somewhere over here I'm gonna define a rectangle, and all the points that will be crossed within the rectangle will be selected. And in this case, I'm also gonna delete them by clicking on OK. There are still some points that we see over here. We have some points. So this is one of the main drawbacks. We need to do another small trap in order to gather them. Other software have let's say better cleaning solution. Also, if you know a better solution to cut those, let me know in the comment section, because within CATIA I didn't find anything that will filter only those that are let's say far from the rest. Usually other software have some kind of noise reduction for this, and this is considered to be noise within the 3D scan. I'm not gonna go and select all those. Over here we see some other points, but I want to discuss about how we can filter this. We see that within that large cut we also deleted some of the elements, so maybe it's recommended to do multiple removal if you don't want to cut anything, but for this case I'm just gonna stick with this. Now if I'm gonna go for information for this point cloud, we see that somewhere around 2 million points have been trimmed within that, and I have the possibility to define a mesh. I'm gonna create one using the unfiltered mesh, but this can take quite a while. So let's see, I'm gonna go to the mesh creation for neighborhood. For this mesh, CATIA is still trying to select that, and over here we're gonna have the neighborhood. So within the mesh creation, regarding this distance in millimeters between points, CATIA will try to draw a surface to draw that mesh. I'm just gonna hit apply, and I'm gonna let this process. Since there are quite a lot of points, this can take several minutes, so I'm just gonna leave it like this. Maybe for the final upload video I'm gonna scale the time for this section. As you see, the load on the processor is not that high, since CATIA is mostly, it's not working with multi-core. So we see that only one of the core is at maximum frequency. So now it's core 5. So if you are using older version of CATIA V5, just like I am, it's highly recommended that you also have an older processor, because older processors, especially those that only have, like, let's say i7 4th generation, that only have 4 cores, also will have a higher clock. So my processor is only at 3.3 megahertz, but some are at, I don't know, even some overclocked close to 5 megahertz. So the processing time within CATIA will be way faster with those one. With more recent processors that have multiple cores, again, CATIA will struggle since it's not a multi-core software, especially with Xeon processors that have a high amount of cores, but they have a lower frequency. So we see that the mesh creation is still not responding. Now, since CATIA is not using only one core at a time, I have the possibility to start a new instance. So this is one workaround if you are working with CATIA Digital Shape Editor. And now, since I started the second instance, we see that it's still not using the processor at the full state, but we see that Windows will start the second instance now. I'm gonna go with no for this one, and within this second instance I'm gonna have that imported again, but I'm gonna filter that before. So Digital Shape Editor, I'm gonna click on OK. Again, I'm gonna import the same model, so from desktop it will be the same file from the previous one. We see the load on the processor now. So this initial load for this one was roughly 1 minute. So I expect it to be even more, since I already have another instance of CATIA running. But I mainly wanted to make this video to highlight the problems with V5 that is not using, let's say, processor full capabilities. Okay, so similar to the last load, I already saw that it started to preload the model. So in several seconds the model should be loaded. Now I have moved the import window over here, so we're gonna have the model center as soon as it will be loaded. If I'm gonna go over here, I still see that this is not responding, but keep in mind that it will slowly process this. For some meshes it can take even several hours to have that processed. And within the second instance, the model should load. And we have this loaded within the second instance. And for this one, I'm just gonna go on filter, and I'm gonna filter this before I'm gonna filter it. I'm just gonna copy it, because filtering a mesh doesn't have an undo button. So it's important, if you want to swap between various filtering options, you can do some with undo, but only several steps. We should have that multiplied now. Okay, I'm gonna hide the initial one, and for the second one I'm gonna filter this. And I'm gonna go with 0.5 with homogeneous. So this will keep the same ratio between within the point cloud. We see that the total number of points will be filtered 18 millions. We see that the remaining points is currently set to 100% because this filter still hasn't been processed. But as soon as the loading will progress, and at the end we're going to see how much of the initial points have been filtered during this operation. So with 0.5 will be quite a heavy filtering. So from the initial 80 million points, we're going to have the remaining points. Okay, and we see that only 0.5 of the initial points have been kept, but we can already see better the profile of this this 3D scan. So it's a bronze statue, a female bronze statue, and I have the possibility to go with adaptive, 0.5 for homogeneous filtering. We're gonna have a 0.062 in this case for adaptive. But the main advantage of adaptive is that in some areas, for example maybe the nose, we're gonna have a lot more points, but in other areas that are flatter, like the points on the table, the filtering will be let's say heavier than on areas where we have details. So I'm gonna go with adaptive. We see like this, we only kept 0.5 of the initial points. So I'm gonna reprocess this using adaptive filter, and we're gonna see how many points we're gonna have at the end. I see that this video is quite long already, so it's 20 minutes, but keep in mind that if you are working with CATIA Digital Shape Editor, you can expect these high processing times, since, as I said before, it's not that great with modern CPUs. Okay, so with adaptive we see that we have 9.39% of the initial points, so we still have over 1 million points. I'm gonna go with OK for this one, and I'm gonna create the mesh. So I'm not gonna delete anything now, I'm just gonna delete it once everything has been meshed. So I go with mesh creation, I selected this mesh. We see that the value was changed to almost 0.6 millimeters, so the distance between 2 points that will be meshed together. And again I'm gonna hit on apply, so this will start to process. And if you're gonna take a look at the load on the processor, we see that there are, in some cases, there are 2 cores that are working at their maximum clock speed. And I have the possibility to swap between those models, but keep in mind that since CATIA is within this not responding state, it takes several seconds to jump between one instance towards the other. But I'm pretty sure that this that has been already filtered will be the first mesh that will be created. If it would have been heavily filtered, like below 1%, the processing time for the mesh creation would have been way faster. But more modern 3D scanning equipments no longer use this ASCII file format for 3D models. They are already meshed models, so we have those points, but they are already joined by a surface. And we see that this mesh creation is close to be processed. If you're going to take a look on the load on the processor, we still see that it's changing the load from a different core to another, which is in some cases quite weird, because once a core has been allocated a, let's say, processing task, it should remain at full clock speed in order to have that mesh prepared as soon as possible, but it seems like it's not working like that. So I'm curious if within 3D Experience the Dassault system has addressed this multi-core processing issue in order to process at let's say a decent speed. As I said before, for some models I've waited even several hours to be processed. This way other software solutions are a little bit better, but the main advantage of CATIA is that you have everything over here. So as soon as you have the mesh ready, you can start to convert it to a different file format and start working with it. So let's see, it's still processing a little bit. So this mesh creation, if I'm gonna jump to the other video, this is still has a lot of processing time required. Also, I wanted to make this video because within one of the recent comments, so let me check that. Okay, let me stop this. Even though it's not using all the processor, it's quite hard to do anything while CATIA is working. Okay, so now I managed to get YouTube starting on the second screen. Let's see, I'm gonna go within YouTube Studio to see that that command. Okay, so I found that command. While it's still processing, we're gonna take a look at this. So we see this was posted 2 days ago. So we see when he okay, so we see this error. Any idea precision? It's a very big STL file. The part where it creates an offset to more than 10 minutes. Okay, sorry about that. And I asked how complex was the model. So we see he used an STL file and I asked if it had more than 2 million vertices. Keep in mind that the initial one has 15 millions, so we see that it's still slowly processing. But this is only the mesh creation. Within this video is for the next part when we're gonna have that surface that we can work with in generative shape design. So during our current processing time, we're just gonna generate the mesh, and after that we're gonna have to generate that one. So this is also why I decided to make this video, in order to showcase the high amount of time required to process meshes within CATIA. I'm just gonna wait because I'm sure that it should finish this processing anytime soon. If not, I'm just gonna mute the microphone and I'm gonna trim this part within the final video, and I'm gonna speed it up. We see that it's 4:32, so I'm gonna stop the microphone and I'm gonna edit this and trim it at the end. Okay, so I see that the processing is finished for this model. I'm gonna go with this value, so I'm gonna go with OK. As we can see, the neighborhood distance should have been way higher because we have a lot of areas that have not been filled. But the initial mesh for this one, so over here we also have a neighborhood of 0.1. Within all this area, the mesh will not be fully filled. So keep that in mind when you are working with this type of meshes, that higher values are required to have the mesh fully defined. And also a drawback, once you finish mesh creation, you will no longer be able to edit that. So you see this is the triangulated mesh in this case. I'm just gonna reveal this again, and I'm gonna filter this quite heavily. So I'm gonna go with 2 millimeters, not adaptive. This should also process quite fast. And I'm gonna create the mesh again for that one. Also, the main advantage of using filtering is that the noise level will be lower, since the sampling points will be at a hair distance. So we see the filtering has processed for these remaining points. Okay, so we see only 0.04 remaining points. I'm gonna go with OK for this one. And for mesh creation, we see a neighborhood that CATIA suggests of 8. So we see the size of that radius. I'm gonna go with apply. I'm gonna see how fast the software managed to do that, since there are only so few points over here. So with 3 millimeters, we're gonna have this mesh created. So we see that within this area we have a value higher than 3 millimeters, so they will not be meshed. But as soon as I go up to 4, all that area will be fully filled. But the main drawback of this is that filter will create a high amount of details to be lost. For example, we see the nose of the statue over here. I'm gonna go with OK. This will be mesh creation 2. And I'm gonna unhide the original one. And we're gonna see that difference in details. So mesh 2, mesh 1 will be this one. And if I'm just gonna hide mesh 2, we see how much detail we had over here. But again, we had that problem of neighboring points, distance not fully filled. So adjusting the filtering parameter is really important. Okay, so I hope you find this video useful. So I see it's quite a long video. On my OBS it's almost 1 hour. After I will process this and speed up the waiting time, it still should be quite a long video. Okay, so thanks for watching. I will also address this direct comment with another video, but I will use again an STL file, so not like this one, just the point clouds, a file that will be already meshed, so this section with create mesh will no longer be needed. Okay, thanks for watching. If you find this kind of content useful, please let me know in the comment section, and also consider to subscribe if you want to see more videos like this one. Thanks.